upon any other service. Okay, so there will be no network latency. Our service don't need to call out other service. Okay, so there will be no network latency. Okay, and it, as I already said, it is easy to develop and test. Okay, because everything is in single space. There will be no issue in the dependencies. Okay, and easy to scale because it is only a single application. And suppose if there is a lot of traffic coming, what we will do, we will spin up new VM or new pod. Okay, and that is scalable. Okay, because we just have to create a new pod only. Okay, or new machines if there is a lot of traffic, so it is very easy to scale. Okay, but it is a single point of view. Okay, in the easy to scale me. Okay,
Okay.
but now if we move to the disadvantages, the limit the disadvantage also is to limited scalability. Scalability means, why it is saying limited scalability? Because this application is a single unit. Suppose there is a lot of traffic in the trending page. Okay, so and it is handled by different APIs. Even it is in a single code, not single jar, but it is handled by different API. Now, if there is traffic in the trending page, and now we have to scale our application. So we are scaling our entire application. Okay, so it is not good practice now. Getting means the only thing need to be scaled is the trending API. But because everything is in only in single jar, we have to scale entire application only for a simple service. Okay, maybe now after some time there is a lot of traffic in the user creation API. Okay, but again we have to scale entire application. Got it, na?
Got it.
Yeah. So it is not cost effective now because we are as it is a single jar, it is a huge jar. Okay, and it will compute a lot of resources. Okay, so as we are scaling the means all the application only because there is some spike in some or some feature. Okay, still we are scaling whole application, so it means limited scalability. And there is next thing is the risk of failures. So as it is a single code, single jar, there is a chance of single point of failure. Means suppose because of some issue, subscription is not working, feature is not working, so because of that our application is going down. Okay, but because subscription thing is not working, but other part is working now, streaming thing is working, there is no error in the streaming part. But because the all the code is in single jar, if one component is failing or one feature is failing, it means all the entire application is going down. Okay, so it is a single point of failure, so it is not a good practice now. Like suppose if you go to the Flipkart, let's go to Flipkart. Suppose now this 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 thing is failing. Okay, card thing is failing, and because of this card thing, entire application is down. We are not able to access on this UI. Okay, it is not a good practice now. Got it, na? Hello.
Correct. Correct.
Yeah. So it is a single point of failure. Even the thing is failing is different thing. Only one feature is failing, but because of that, entire site is down. So this is called single point of failure. And the third part is technology locking. Technology locking means suppose initially we are started to create the application in the Java or Spring Boot. Okay, now we have to add new service. Then again we have to update the same code. So in that case we have to use the Spring Boot only. There is no chance of using different code or different databases. We have to only go with the single thing. Okay, we have that it will be technology locked. We can suppose if you want to use a Python, okay, for new feature, it is not possible now because everything is in single repository and it is using same language. Okay, so it is very difficult to means to switch to different technology. Okay, so this is the third disadvantages. Got it? Everything clear about monolithic?
Yes.
Yeah. Now let's move to the microservice architecture. So what is microservice architecture? So in this case, the developing software application that consist of the small, independent, and loosely coupled services. It means that we will be creating an entire application, but we will be dividing that application into different components. Means suppose this is our dashboard thing. Okay, it is one thing. Okay, its functionalities only show the primary thing. Okay, basic thing. What is the component? All those things. Now suppose if you want to go to the grocery thing, if you click there, okay, it means there will be some different service like product service, something other service which is handling all this thing. All this thing is shown by other services. Okay, so it means we are dividing a single application into multiple services. Now there is a, suppose if you want to add something in the cart, okay, for that we will be creating a different service for adding the item into the cart. Okay, and then next thing, if you want to create a payment, we have to do a payment. Then for that we will create a different service for the payment. Okay, and a different service for creating a user. Okay, all service, something like that. Okay, so it means we will be creating single application, but still we are dividing that application into the multiple microservices. Okay, and these microservices are independent. Means this front thing is independent of the grocery thing. It doesn't care, okay, if this is working or not. Okay, it's only showing this basic page, basic thing, what they have to show. They don't know, okay, this part is working or not, this thing is working or not. They are not sure. Its only responsibility is to show this page, okay, or render this, only this kind of things. Okay, suppose there is some issue in this, like suppose if you want to buy some, like some package, if you click here, okay, add item. Suppose there is some for that also we are having some different service, like card service. We will say like card service. The card service handling all these things. Suppose user has like 10 things in the card, all these things is managed by different service. Okay, so it means this thing is different service which is handling the or showing all the dashboard to the UI to user. Okay, basic things, and there will be different services for other application, like adding an item to the cart, showing the all the entire thing, description of the particular product. Okay, here we can see this service is showing us the description of particular item. Okay, so it is handled by different service. Okay, so application is divided into multiple small independent loosely coupled. Loosely coupled, it means this thing, this service is not related to this service. Adding card, all those things. Okay, it is only responsibility is to show these things. Got it, na?
Got it.
Yeah, and each service runs as a separate process, as you said. Like there will be different pod or different Docker images for each of the service. Okay, and all these services will communicate with each other using APIs. Okay, yeah. So this is about the microservice architecture. Now let's move toward the scalability. Okay, and the advantage of this microservice architecture is scalability, because as we are saying, like these are the different we have different services for each and every feature. Okay, and next, like suppose in future if you want to add like wish list item thing, actually, okay, so we will create a different service for that. Okay, so suppose there is some spike during, like we have added some sale. Okay, so big billion day. In that case, what will happen, there will be spike in some of the categories, like uh, showing the mobile, all those showing the product. That service will be huge spike during big billion day. So what we'll do, we'll only increase that particular component only. Okay, means are you getting, means what I want to
Yes, yes, yes.
okay.
Because if like they are doing some offer on the iPhone only, right? Mobile category.
Yeah, so in that case, in this case, what we'll do, we'll only scale the service which is handling this particular items. Okay, showing the items. Okay, this service only. Got it. So we can scale a single service. Okay, we are not scaling entire application. We are only scaling the only single service. So that is advantage now, because single service is taking like pure memory. Let me show you on the like text file maybe. Uh, like suppose this is our Flipkart. This is a monolithic one. It means single Docker image. Okay, so this is monolithic. Now, if you are moving with the microservices, it means here we have different services. Like for showing the product, we have one service, adding cart handling, delivery, delivery, delivery handling. Okay, and then like shipping related activities, shipping, and there is authentication or user service. Okay, so suppose in the big billion day, what will happen? This service means lot of people will try to see the lot of products, right? In that case, what we can do, if there is spike, we'll increase the pod to 100 for this particular product, okay, or we'll only scale this particular application, okay. So it means this application is taking only like 13 MB, okay, say for just simplicity we are saying this application only take like 30 MB, and this take like 40 MB, 40 MB, 13, okay. But this entire application takes like around 1 GB, okay. So in that case, if you want to scale this application, it is very difficult. Now suppose if you want the huge traffic is coming, and now we have to create a new instances for that, like now we have to create a five images, okay. In that case, the total capacity will be 5 GB, okay. We are creating new uh, instances with the uh, 1 GB. So total memory is 5 GB. But in this case, here only because the service is separate, we are only creating 5 pod of this particular service. It means 13 into 5 is equal to, I think, 150 MB. Okay. So it means it is highly scalable. Okay. We can scale it to like 100 pods also. Okay. What is the scalability factor here?
Got
Hello.
it.
Yeah.
Yes, got it.
Yeah. Now, second thing is fault tolerance. As we see in here in the monolithic, suppose because everything is in only single code, suppose this thing is failing, delivery thing is failing, okay, card handling is failing, in that case entire application goes down, okay. But in the Flipkart thing, sorry, in the microservice way, because everything is deployed differently, we have separate image for each and every application. Even though this thing is failing, our application is still up, okay. You and what we can do, we can tolerate that fault, we can handle this exception exception that this thing is failing, okay. We will just show here like, okay, right now we are not able to add the product into cart, okay, please try after some time, okay. So we can tolerate this particular thing, but our entire application will not go down, okay. Getting na? Hello.
Yes, getting.
Yeah. So failure in one service does not bring the entire application down. And the third thing is technology diversity. As said, because every service is separate microservices, we can create a, you can use the different, like suppose for this thing, little thing, we want to use the Python or from Flask, Django, we can use it, okay. Suppose for card handling, I have to use like Golang, okay. For shipping data, I want to use Spring Boot, okay. That is totally possible. I want to use the MongoDB. That's totally possible because each and every service can have same or different kind of technical set. Okay, but in case of monolithic, it is not possible because everything is in single code. So we have to only, if we started with the Spring Boot, then we have to only use the Spring Boot only. Okay, got it, na?
Got it.
Now let's talk about the disadvantage of the microservices. Yeah, so the disadvantage is that, so it is very complex because we have to handle like multiple services, because once the product gets bigger and bigger, maybe there are like a lot of services, like there will be 13, 20, 30 services. So it is very huge task to manage all these services, to get the track of all the services, okay. So the complexity will increase after some times, okay. So it will require additional infrastructure and resources to operate, okay. So this is the disadvantage. Yeah, the second thing is because suppose in the like after some year, because we want to add new feature and we are going to create a new service for each and all these things, so it is very difficult to manage all these services and handle the traffic between, so handle the interconnectivity between the services, okay. It requires a robust service management to ensure that all services are working together and seamlessly. Okay, so we have to create a good architecture for that. We have to create services in such a way that they will not depend upon each other. And but it becomes very tedious task to create such architecture once the application grows or infra grows. Okay, so this is one downside. And the third thing is testing. As in case of monolithic, because our application is single thing, we can test only single application. There is no dependency. But in case of here, we have dependency now because there are different microservices, different services, and they are dependent. There will be some dependencies, small, like this card thing will call the auth or user service, okay, to get the address of that particular user, okay, for shipping. Okay, so there is some dependency, but to test this thing, we have to create these two services. Okay, we have to spin this pod, we have to test it. Okay, so once the application grows, it is very hectic to test this application. Okay, so that is a one disadvantage of the microservice architecture. So any doubt?
No, as of now.
Okay, so I think you're clear with this thing. So we can move ahead. Okay, so in that is why there is a thing called Kubernetes. Okay, so why we need Kubernetes? Because in the microservice architecture there will be a lot of services, and it is very hectic to manage these services. If you are going with the EC2 machines, so it is very difficult to scale this EC2 machines because like there will be 90 services, 100 services. So we will require more people, like 6 to 10 people, just to manage 3 or 4 services. Each will see the EC2 machines, what is the access required, how to spin it, how to scale it. So we have to uh, manage all those things. Okay, and it becomes very hectic. But Kubernetes help us in that way. Like we will only require few resources because all this like scaling part will be done by the Kubernetes, and to spin up the Docker images. Okay, to handle Docker container, all things is done by Kubernetes. Okay, so it is a powerful platform for managing container application. Okay, so as I said, like it can manage the scalability because it has like HPA, horizontal polar autoscaler, or VPA, vertical polar autoscaler. So depending upon like CPU uses, memory uses, or API request uses, it can scale the pod up and down. We don't have to means we don't have to put the particular people to watch this uses. Okay, we don't have to put anyone. It will automatically detect. It will automatically fetch the matrices, and depending upon the matrices and our threshold, it can scale the application. Okay, so we don't have to dedicate person for this. Okay, that is one advantage of the Kubernetes. Second thing is highly available. Okay, because Kubernetes, we can create a HA, like we can have multiple masters and worker nodes. So suppose even if one node goes down, we can spin up a new node. Okay, because there are lot of nodes are available. Okay, we can create it easily. So it is very highly available. So even like suppose we are creating like 10 or 20 nodes, even the 2 nodes went down, our application will not affect anything. We can shift the pod from one node to another node, but it will be done automatically by Kubernetes. Okay, so our application is always highly available. But if there is no Kubernetes, the issue is like suppose if you are managing with EC2 instance and so, because of some reason these two instances went down, so it is difficult to spin up an instance. Okay, we have to again we have to check it, we have to add some auto scaling group, something like that, and it will take some time to spin up the new machines. But in case of pod, it will be spin within like seconds or minutes. Okay, and the next thing is portability. Portability means like we can spin up the Kubernetes cluster on the bare metal. Like if you have some VMware or virtual box on your local machine, you can create a Kubernetes cluster. You don't have to depend on the clouds. Okay, but also there are multiple clouds which offer managed Kubernetes clusters. Like in case of AWS, it offers EKS. In case of Azure, it offers AKS. Okay, and in case of GCP, it offers GK, right? Hello.
Right, sir. Right.
Yeah, I thought you left.
No, 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 no. I was on mute, na. Some noise are
Okay,
coming.
okay,
That's why.
okay, okay. Maybe it is boring, okay, at this time, but we have to understand the theory why we need it. Okay, okay. And the fourth thing is automation. So as I already said, all these things are managed by Kubernetes, means updating the deployments. Okay, updating the pod, scaling the pods, creating the pod, creating the containers. All these things are automated. So the manual work is very minimal. Lot of things are automated by Kubernetes. And the fifth thing is ecosystem. Like we have a lot of tools, plugins built around Kubernetes. Okay, like Grafana Loki, uh, like Prometheus, all those things supports Kubernetes to fetch the logs, matrices, everything. Okay, like also there is the Istio is there to manage the service. It is a service mesh to manage the all the microservices to monitor the traffic. Okay, to create a dashboard. There is a KLis available. So there is a like lot of tools and plugins are available or built around the Kubernetes. Okay, so it is very easy to monitor your application, to check the logs, to check the security of your application, and you can easily integrate these particular tools. Okay. Okay, so this is about the Kubernetes advantages, why we use it. Okay, means you got it, at least some clarity why we use it.
Okay.
Means really means you are getting the part or not?
Yes, yes.
Yes,
yes. No. I'm understanding it. Not a problem.
Okay. Now, apart from Kubernetes, there are some competitive to Kubernetes, like Docker Swarm is there. Docker Swarm is created by Docker. Okay, you can use it, but it is not as good as the Kubernetes. Okay, you can use a Docker Swarm. I think people are still using it. Some people, okay, because Kubernetes like it requires lot of, not lot of, but at least some compute power. Okay, so because of that, some like small startup which have very low budget, very low, they will prefer Docker Swarm. But I don't think so. It is a good idea because currently there are a lot of data available. Like you can use the Minikube K3s or just which are very less, which take less compute power. But only matter is that we have to manage the cluster. The difficulty is to manage the cluster in the Kubernetes. Okay, that is only downside. But if you are using some cloud providers like AWS, they are already providing like services like EKS. Okay, so we don't have to worry. Okay, then there is a thing called Apache. Apache means is also there, and there is also like something close to Kubernetes is the Nomad. Okay, it is created by I guess I think HashiCorp, which has like lot of tools like Terraform, Vault, all these things is created by HashiCorp Vault. They also provide the COE. COE means Container Orchestration Engine. Okay, Nomad. Okay, so these are the alternative to Kubernetes, but I don't think some people are using other than Kubernetes because it is very popular. Okay, so Kubernetes is the most popular widely adopted COE tools for good reason because it offers portability, scalability, resilience, and ease of use. Okay, and there is also now I think new tool called Crossplane. Okay, they like it is alternative to Terraform. It is totally dependent upon the Kubernetes. We have to only go with the Kubernetes only. Okay, so there are a lot of things are coming in Kubernetes which are very new and exciting. Okay, so this is about the monolithic architecture and why we need Kubernetes. Okay, and what it offers. Okay, got it now?
Got it, sir.
Okay, where is the architecture? Okay, it is below. So introduction will cover today. So let's go with the architecture again. Yeah, this thing we have already covered. Okay, but let me revise it again. Okay, because you have to understand this thing. Can you please explain the architecture of the Kubernetes?
Okay. So I will explain. First, we have API server. API server always take the instruction, whatever instruction we are giving through with the help of the kubectl commands, right? Or UI. So it's always give instruction, whatever the instruction we are giving, like we want to create, we want to get any information. So it will work API server responsibility, correct?
Right.
Now, second one is etcd. Etcd is a copy of all the configurations. Whatever the configuration we are doing it, it contains all the copies of the configurations.
Okay, it is not a copy. Copy means
The
there
configuration.
means all.
The
Yeah,
configuration.
it is a storage for all the configuration. You
All
cannot
the,
say the copy. Okay, it is like a it is a database. Okay, key value databases. All the configuration is stored in the etcd.
okay.
Okay.
And there is a one called scheduler. Scheduler responsibility are to just to create a Docker over the nodes, worker nodes.
Not at all.
And
It responsibility of the scheduler is to schedule a pod on a particular node. Okay, that's it. Depending upon the node affinity and all other parameters which is given by the user.
okay,
Okay.
On the port, right?
No, not a pod. Pod is different. Yeah. So let me explain it once again. So Kubernetes architecture consists of the two part. I mean, main two component. One is the master node. Or somebody also call it as a control plane. Okay. Okay. And then there is a worker node. Okay. So these are the main two components. Okay. Now in the master node there are sub components. Okay. It is a central control plane that manages the entire cluster. So master node manages everything. Okay.
Okay.
Its task is to scheduling, scaling application, monitoring resources, managing cluster security. It task means it is done by their subcomponents. Okay, like as you said, scheduler, controller manager, okay, API server. All those things are the part of the master node which done all these activities. Okay, so what is responsible? It is responsible to scheduling and deploying the container on the worker nodes. So here the schedule component will help us to schedule the pod on the container on the worker nodes. Okay, it just say that okay, deploy this application on this particular node. It actually does not deploy on the node. It just say that okay, just deploy this application on this particular, assign that pod to particular node. Okay. Application up and down. So it is done by the control manager. So there are various control manager available. We will going to see the list of it.
Hello.
Hello. Yes, yeah. So this thing is done by the control manager. Next thing is managing network communication within cluster. Okay, so for that we will install the plugins. Okay, we are going to see that also. Okay, and then there is a managing authentication authorization for Kubernetes resources. So for that also we have different controller, like admission control is available, admission and webhooks, admission webhook controller, something like that. Okay, which handles the authentication authorization for the Kubernetes resources. Okay, that thing also present on the master node. Okay, handled by master node. And then there is a providing an API endpoint, the Kubernetes command line, another one. Okay, so what it meaning? So it provides the API endpoint. Okay, which is the API server. Okay, okay. So API server is provide endpoint for other application to interact with the Kubernetes. Okay, so these are the basic task of the master node. And for to achieve this thing, it uses the some components like API server, etcd, kube scheduler, kube control manager, and there is a cloud control manager. Okay, got it, na? Hello.
Got it.
And so yeah, as we let me iterate with this again. Kube API server, it is an endpoint. Okay, so it is entry point for the any request have to go through the API server only. Okay, so it is entry point for any request to the our Kubernetes cluster. Okay, so all these things like authorization, validation, all those things will be handled by the Kube API server. Authorization means suppose someone want to access our Kubernetes cluster, they need to pass credentials. Okay, they have either there will be service account, something will be there, some credentials. Okay, in the case we will use the IAM roles or users. Okay, to authenticate with the cluster, but that that request will go to the kube API server, okay, which will do all the authentication part. Second thing is validation. Validation means, like, suppose if you are creating some resources in the Kubernetes, okay, like pod, there will be error in your YAML file, okay. That thing has to be validated by the kube API server, okay. Got it? Yes. Validation means it will validate the YAML file also.
Okay.
Okay, so that is the responsibility of the QA API server. Why I'm explaining this thing? It will be helpful for you in a debugging as well as in future interviews.
Okay.
Because they will mainly ask what is the architecture of the Kubernetes. It is the main question. Second thing is etcd. So as we said, etcd is a database. It is a key value database for our Kubernetes cluster. We store all the cluster data including configuration and state information. Okay. Next thing is kube scheduler, which is responsibility schedule the pods to run on available worker nodes. So it just schedules the pod on the worker node. It does not create a pod on any worker node. Just understand the difference. It only say that, okay, we have some request. There is a new pod, and now we have to schedule it on the some worker node. So it will just give it, okay. It will just attach a label to that particular pod. Okay, just run this on this particular node. Okay, and the creation of this pod or container is done by kubelet. Okay, and the next thing is control manager. So there are a lot of control available. Like, suppose if you want to scale the application, then there will be a replication controller, which handle all these things. Suppose if you want to attach a volume, then there is a volume controller. If you want to create snapshot, there is a snapshot controller. A lot of controllers are available in the Kubernetes, and all these things is handled by the control manager. And this thing we can skip. It is not for the bare metal. Okay, this thing is not that important. Okay, so that is the node role of the master node components. Second main feature of the Kubernetes, second main component is the worker node. Okay, so nodes are the working machine that run the actual workloads in the cluster. Okay, so these are like simple VMs. Okay, means we can create any number of nodes. Okay, it is like a we can treat data as like there is some code. I don't remember the code. Okay, but it is just like we can treat them as some I will not use it. Okay, so it is just like a simple worker machines. We can create as many as we want. We can create it, delete it, create it, delete it. There is no means anything. Okay, because all these things, main things handled by master thing, and all this pod running is done. Is creating the pod and container is done on only worker node. Okay, only provide the compute thing. Okay, that's it. So each node runs container runtime such as Docker or Containerd and Kubernetes agent called kubelet. Okay, so kubelet is run on each and every node. Even this thing is present on the master node. Okay, don't forget it. Whatever is available on the worker node, same thing is available on the master node, because we can create a pod on the master node, but the recommendation is to not to create a on the master node. Okay. Got it, na?
Got it. Got it. Got it.
Yeah. Now let's see what is the responsibility of the worker node. So worker node in the Kubernetes cluster runs the application containers and provides the compute resource needed to run those containers. Okay. As I said, it will just a compute machine. It will just provide us some computation power like RAM, CPU, all those things to run our pods.
Okay.
Worker nodes are responsible for running the pods that are scheduled on the Kubernetes control plane. Like all those things, like pod will be scheduled on the worker node by the Kubernetes control plane, means the scheduler. Okay, they will schedule the pod on the worker node, and the worker node responsibility is to just to create that pod. Okay, and that pod is created by which component?
What is created by the scheduler, right?
No. Yeah, that is what I'm saying. Scheduler just schedule the pod on the worker node, but the pod creation is done by kubelet.
Okay, kubelet. Okay.
Okay, they will lot of time they will ask you what is a kubelet, what is a static pod. Okay, so this is related to kubelet. Okay, and worker node also create scale and the up and down the pods. Okay, it will scale the containers up and down. Okay, but means the order is given by master only. Okay, scale this particular pod or on those things, but it will be done on the particular worker node. Na? Okay, so that is the responsibility of the worker node. Let's go with let's check the components of the worker node. So the main thing of the worker node is the kubelet. Okay, what is the responsibility of the kubelet? So kubelet there will be separate kubelet for each and every node. Okay, and that kubelet is responsible is to create a container on that particular node. Okay, and it ensures that the pod is created, it is up and running. It will send the status of the particular pod and all those things. It will means it will make sure that this pod is up and running. Okay. What is the status like? Suppose if you want to delete a pod, that request is go through API server. API server will tell this to the some controller. The controller will send that request to the worker node, and the worker node will send this request to the kubelet. Okay, and then kubelet will delete that pod or scale that pod. Okay. Now next thing is the kube proxy. So kube proxy, the what is the kube proxy? Can you explain? Hello.
Yes, yes.
Yeah, can you explain what is use of kube proxy?
Proxy are responsible for balancing the load between the services and also provide the connectivity of the internet also, right?
Right, not the internet, interconnectivity.
Internet.
Interconnectivity means we have to suppose one pod want to connect with another pod.
Okay.
Yeah. So yeah, so it will handle the interconnectivity between these things. So how it handles? It handles using the IP table. Okay. We are going to see this thing in a deep also. Okay. So we will see, 2 or 3 days we are going to only look at the architecture. Okay. Now, next thing is container runtime. Okay. So what is the container runtime?
No idea.
Okay. So container runtime is like a Docker. Docker is a container runtime. Okay. So and there is also alternative to Docker. It is container DCRO. So all those things are the container runtime. Okay. So there is a thing called CRI. CRI means container runtime interface. And what is interface? It just said some standard. Okay, like we have to do this thing in some manner. Okay, and those interfaces is implemented by these plugins called Docker, Containerd, and CRIO. So even though our kubelet do the like creation of the container, all those things, but it is actually done by the container runtime, which is Docker. Okay, so it is like everyone is delegating their responsibilities to some other person. Okay, like suppose if you want to create a pod, we will say this thing to the API server. Okay, please create a pod. That API server will send that request to scheduler. Scheduler will send that request to particular node. Node will send that request to the kubelet, and kubelet then send that request to the container runtime, which is Docker and Containerd. Okay, got it? Na?
Got it.
Yeah. So these are the components of the worker node. And third thing is the etcd. Okay, so actually means suppose they will ask what the architecture of the Kubernetes, just say that it is consisted of the 3 parts. One is the master node, second is the worker node, and third is the etcd. But sometimes what happens, they means they will create etcd cluster inside master itself, master nodes. Okay,
Okay.
but actually it should be means in ideally it should be different from the master node.
Okay.
Okay, because suppose if master nodes went down, what happens? Our etcd cluster also goes down now. Okay, if they are on the same machine, then our entire cluster will be gone. We cannot access our pods and all those things. So because of that, etcd should be in the different machines for the best practices. Okay, and what is etcd? So etcd is a distributed key value pair that stores the configuration of the data for the Kubernetes cluster. So it stores everything like cluster data, secrets, application state data, everything. And all these things you can read it here. Okay, I'm not going to explain now each and everything. Okay, I think that is enough for today, or should I go?
Yes, it's enough.
Okay, so that was only overview. Now in like tomorrow's lecture, we are going to see everything in detail. Not
Okay.
again. Means, do you want me to cover this thing in detail, or
Yes. Yeah, better. Yes, we can do it.
So I guess architecture we are already gone with this thing.
Yes.
It is and once we cover the Kubernetes, then we'll cover piping. That's it, na? That is our mode. Hello.
Right.
Receiving master components. Yes, server. Controller manager. Scheduler. Okay, lot of things are there.
Yes.
Means you don't have to remember everything. You don't have to remember functionality of each and everything. Only thing you have to remember means the main components. Okay.
Okay.
Third, three main components and their subcomponents. Okay, just remember those things.
Okay.
Okay, I guess that is enough for today.